Have you ever stopped to imagine what an alien greeting or even a warning might actually sound like? Not the cinematic, orchestral take me to your leader kind of thing, but a real interstellar signal sent not in words or melody, but through mathematics, radio bursts, and the faint hum of the cosmos. This isn't just science fiction, it's the frontier of one of humanity's oldest and strangest dreams, that we might not be alone. And that somewhere out there, someone could be trying to say hello. Tonight, we're dissecting the science and the speculation. Look at why we listen for sounds in a silent universe. We might recognize a true alien message when it comes, and what it would mean for science, for humanity, and for the story of who we are. Every great mystery starts with a single piece of evidence, and ours begins in 1977 at Ohio State University's Radio Observatory. A researcher spots something unusual on a long roll of data paper, a sharp spike of radio intensity from deep space. It's clean, narrow, strong, and gone within 72 seconds. He circles the data in red pen and writes one word: wow. Decades later, the wow signal still defies easy explanation. It didn't match any known satellite or astronomical source, and for all our searching, it has never repeated. Is that surprising? Maybe not. The space between stars is vast, and if an intelligent civilization wanted to send a message, we might only ever catch a fleeting glimpse, a cosmic postcard dropped on the wind. What makes the wow signal fascinating isn't just its mystery, but its temptation. For the first time, scientists allowed themselves to seriously wonder, what if that burst wasn't just natural noise? What if it was deliberate, a transmission meant to be found by someone listening? Today, approaches to that question are far more sophisticated. Modern projects like the Square Kilometer Array, a massive network of radio antennas spanning multiple continents, are taking our ability to listen to an unprecedented level. The SCA isn't just scanning, it's filtering, categorizing, and cross-checking thousands of frequencies, simultaneously building a constantly updated map of what's natural and what might not be. But when we talk about what an alien message sounds like, we're speaking metaphorically. In space, sound doesn't travel. There's no air for vibration. What we actually detect are radio waves, oscillations of energy. Scientists convert those signals into sound files so we can experience them through something we can perceive, hearing. Those tones, the steady pulses, the descending sweeps, helps us spot patterns our eyes alone might miss. So when someone says they heard the wow signal, they really mean they listened to a translation, a bridge between the invisible and the audible. It's not sound as we know it, but sound as a symbol. It might seem strange, even poetic, that humans would dedicate entire observatories to listening for a sound the universe may never make, but at its heart, listening is what we do best. Listen to weather, to seismic data, to the heartbeat of stars, even to the microwaves left over from the Big Bang. Sound, or something like it, is our most primal way of finding order in noise. Space, on the other hand, has its own symphony, one too vast for human senses alone. By translating it into sound, scientists bridge the imagination gap. It lets us feel what's out there, not just analyze it. There's something deeply human in that. We're not just trying to understand the cosmos. We're trying to hear it. Some scientists think our first interstellar conversation might already be in progress, carried by stars themselves. Take pulsars, for example. These are the ultra-dense remains of exploded stars, only a few kilometers wide, spinning hundreds of times per second and sending out precisely timed radio pulses. Their rhythm is so strict that pulsars act almost like galactic clocks. When pulsars were first discovered in the 1960s, researchers were so puzzled by their precision that they jokingly labeled the signal LGM1, short for Little Green Men. Of course, they turned out to be natural, not artificial, but the nickname captures something essential, that we recognize structure as a sign of thought. Here's why that matters. If a civilization wanted to send a message across the stars, they'd need a universal language, one that doesn't rely on spoken words or visual context. Mathematics fits perfectly. The ratio of primes, the geometry of pi, these are constants that should be the same anywhere in the universe. Whether you're made of silicon, carbon, or something we've never imagined, 2 plus 2 still equals 4. That's the foundation of the beacon hypothesis. It suggests that if intelligent life wants to be found, it wouldn't make things too complicated. They'd send something simple, a clean, repeating pattern, a hello made of numbers, something unmistakably structured but also easy to recognize, even by a civilization still learning to listen. So maybe the first contact won't be an essay. It might just be a pulse, a clear, rhythmic "we are here." But simplicity might not be enough for a truly advanced culture. Imagine you're part of a civilization capable of manipulating energy across light years. Wouldn't you want to say more than just hello? That's where complexity enters the conversation. Scientists have modeled theoretical alien transmissions that could carry vast amounts of data, essentially compressed packages of knowledge encoded into radio waves. Think about sending a high-definition movie or an entire library through a single modulated signal. These ideas sound speculative, but the mathematics is real. Data compression, encryption, error correction, all tools we already use in human-made signals could also apply to an interstellar one. The difference: we might not yet know how to read the alien version of the code. There's another angle too. What if the message is visual? Some researchers have experimented with turning radio signals into pixel matrices. Feed the right sequence into a computer, and suddenly a stream of waves becomes an image or the digital equivalent of a picture drawn in static. It's a thrilling idea. Somewhere, a civilization could have sent an encoded mural, a planetary postcard, a snapshot of who they are, and it's all buried in the static we record every day. What if, without realizing it, we're already storing the voices of civilizations that existed millions of years ago, waiting only for the key to unlock their meaning? That's the haunting beauty of the message in a bottle hypothesis. A signal doesn't need to reach anyone right away. It just needs to survive long enough for someone, someday, to find it. Over the past decade, the search for alien signals has changed dramatically. Once we relied on human intuition, someone staring at a graph, noticing a strange spike. Today, artificial intelligence does that job on a cosmic scale. AI systems analyze massive databases of radio signals, looking for patterns buried so deep in the noise that no human ear could isolate them. They can detect subtle resonances, non-random timings, or anomalies that repeat across frequencies, clues that a signal might not be purely natural. And here's where things get eerie. Sometimes these algorithms find signals that seem organized just enough to raise questions, but too ambiguous to classify. They might be natural, artificial, or something else entirely. The biggest challenge is defining what intelligence sounds like. A repeating pattern isn't enough. Even weather systems can create rhythm. True intelligence has to suggest intent, structure, serving a purpose. But if the mind behind a signal is truly alien, how could we ever be sure we recognize its purpose at all? What if a message is sitting in our archives right now, one we dismissed as background noise because we didn't know how to listen properly? Or stranger still, what if we do interpret it but get it wrong? It's humbling to realize that first contact may not come with a clear hello. It might come as uncertainty, a subtle anomaly that forces us to think differently about what it means to communicate. Let's imagine, just for a moment, that we receive the undeniable, a signal so structured, so mathematically precise, that there's no doubt it's artificial, humanity's first verified alien message. The moment that happens, the next question is immediate. Do we respond? This is called the reply protocol debate, and it's one of the most contested ethical discussions in science. On one side, caution. Some experts warn that responding could expose our location to unknown and possibly dangerous species. They invoke historical analogies, encounters between civilizations on Earth. The more powerful one rarely showed mercy. On the other side, optimism. Others argue that refusing to answer is antithetical to science itself, that curiosity and connection are core to who we are. They say the moment we hear from another intelligence, staying silent would be the loneliest decision humanity ever makes. We've already taken that first step once. In 1974, the Arecibo message was beamed toward a star cluster 25,000 light-years away. It contained information about DNA, our solar system, and even a crude map of the human shape. We might never know if anyone received it, but it proved something powerful. Communication is a form of self-definition. The messages we send say as much about us as any response ever could. So what would we say if we truly heard back? Would we speak in math, in emotion, in art? Would we send music, our most universal form of organized sound? Or would we send silence, letting the message of our existence speak for itself? Beyond the science, there's a more profound layer to this story, one that touches on who we are as a species. For thousands of years, we've looked up and wondered if we were alone. The search for alien intelligence isn't just about finding others. It's about confronting the meaning of our own existence. If we find a message, it would mean consciousness isn't unique to Earth. The universe would no longer be an empty backdrop, it would be alive with thought. That realization could reshape our philosophies, religions, and even our sense of purpose. And yet, there's another possibility that despite all our listening, the universe never answers back. What if the cosmic silence itself is the message? What if we are the only ones capable of asking the question? Either outcome contact or silence carries its own kind of the act of listening, of reaching out into the unknown, has already changed us. We've built machines that can hear galaxies. We've trained algorithms to discern the whispers of the universe. In the process, we've reminded ourselves what curiosity sounds like. So, what might an alien message truly sound like? Maybe rhythmic, maybe mathematical, maybe incomprehensibly strange. But perhaps the real sound of intelligence isn't buried in a radio wave, it's the steady, determined hum of us listening, and maybe, just maybe somewhere in that vast silence, something is listening back. Every time we point our instruments toward the sky, we're not just listening for aliens, we're listening for connection. Listening reminds us that curiosity is our oldest instinct and wonder is our most human language. The truth is, we don't know where the next signal will come from or if it will come at all. But that's not the point. The point is that we keep listening, because somewhere beyond the static and the silence, the universe might just be waiting for someone who's paying attention. I'm John, and this has been Decoding Interstellar Signals, what alien messages might sound like. If you enjoyed this episode, share it with someone who's ever looked up at the night sky and wondered what's out there, and join me next time as we explore another mystery written in light, sound, and silence. Until then, keep wondering, keep listening, and keep looking up.